Why is it difficult to send humans beyond the moon? Despite our achievements in space exploration, sending humans beyond the moon remains a considerable challenge. While we managed to put astronauts on the moon more than half a century ago, we have not gone beyond since then. Even if we were to return to the moon, going any further would be tough due to the technology required, which is still in its early stages of testing. The difficulty lies in various factors, with cost being a major challenge. Sending missions beyond the moon is much more expensive than lunar missions. For instance, NASA spent about $25 billion on the Apollo program to reach the moon, but sending a human crewed mission to Mars would cost at least 100 times more. The immense expense is a significant deterrent as no government or company is currently willing to invest such a substantial amount without immediate benefits for humanity. Moreover, there are numerous technical and physical obstacles to overcome before we can send humans to other planets. These challenges demand innovative solutions, making the journey beyond the moon a formidable task. As a result, we still have a long way to go before humans can explore the vast expanse of space beyond our closest celestial neighbor. One of the most significant challenges for human space travel beyond Earth is the issue of radiation. When astronauts venture beyond the protective shield of Earth's magnetic field, they encounter much higher levels of radiation than what they experience on our planet. This increased radiation exposure can have severe long-term effects on their health. During the short trip to the moon, the astronauts did not face significant radiation risks because the mission lasted only a few days. They were mostly inside the spacecraft, which had special coatings to shield them from radiation. However, on longer journeys, the situation changes. Even with advanced protection systems like those used on the Apollo spacecraft, there are radiation particles from deep space that cannot be fully insulated against. While brief exposure to this radiation is not harmful, missions lasting several months or years can cause long-term health problems, including cancer and DNA damage. Scientists are actively developing advanced radiation protection technologies like radiation shields and improved shielding materials to address this problem. However, currently, no spacecraft can fully protect astronauts from radiation during extended periods in deep space. Finding effective solutions to the radiation challenge is crucial for ensuring the safety and well-being of future astronauts on long-term space exploration missions. Sending humans beyond the moon presents numerous challenges. One major issue is the lack of access to essential supplies like food, water, and oxygen in space. While short missions to the moon could carry enough resources, longer journeys to destinations like Mars would require sustainable supplies. Solutions involve sending a separate supply ship ahead of the crew to await their arrival, equipped with everything needed for an extended stay. Additionally, psychological and communication challenges come into play. The prolonged isolation during a trip to Mars could impact astronauts' emotional well-being, necessitating mental preparation and monitoring. Furthermore, the vast distance between Earth and Mars results in communication delays of up to 22 minutes, making real-time decision-making difficult. These technical and psychological hurdles highlight the importance of thorough planning and ongoing research to ensure the success of future deep space missions. Venturing beyond the moon poses significant technological challenges. Traditional chemical rockets used for moon missions lack efficiency for longer journeys. To reach other planets, more advanced propulsion systems like plasma engines or ion engines are required, offering greater speed. Furthermore, advanced life support systems are crucial to sustain astronauts during extended trips, requiring water and air purification, recycling, and food production. Protection from radiation is also essential to ensure astronaut health. Developing space vehicles capable of withstanding long travel, radiation, temperature changes, and zero gravity presents another obstacle. Achieving manned missions beyond the moon depends on technological advancements and substantial investments in space exploration. NASA's Artemis program, aiming to return astronauts to the moon by 2024, marks a vital step toward deep space exploration. For Mars missions, NASA targets the 2030s, with progress depending on technological developments and collaborations with other space agencies. establishing a lunar base is a crucial step towards going beyond the moon. Currently, this remains a significant challenge as we need to govern the moon effectively. Scientists are exploring the possibility of using the moon's regolith layer, consisting of dust and loose rocks, to construct protective structures like habitats and lunar bases for astronauts. A lunar base would serve as a pivotal stage in human exploration, allowing us to study the moon and use it as a launching point for manned missions to other planets. However, building such a base demands advanced technologies for construction, power supply, life support, and radiation protection. Despite the challenges, establishing a long-term lunar base offers the potential for continuous scientific research and technological development, ultimately propelling us beyond the moon in the near future. A historic and challenging mission lies ahead if we aim to go beyond the moon. Such an endeavor requires meticulous preparation and advanced technologies, driven by the brightest minds in humanity. The crew would consist of highly trained astronauts with diverse skills, possibly 4 to 6 members, promoting inclusion and diversity in space exploration. The mission's duration would depend on the destination, with Mars missions possibly lasting several years, including travel time and time on the planet's surface. Advanced propulsion, navigation, and communication systems are essential to ensure astronauts' safety and successful return to Earth. Despite the technical difficulties, humanity's progress in deep space exploration brings us closer to the realization of a human-crewed mission beyond the moon, inspiring innovation and discovery with every step into the unknown. So, let's keep dreaming, let's keep exploring, and let's keep looking for new ways to discover our universe. Because ultimately, it is the human spirit of exploration and discovery will lead us to reach for the stars. And you, when do you think we'll see the first human-crewed mission beyond the moon? Let us know your opinion with your valuable comment.